Today we're going to talk about the binomial distribution. So the binomial distribution is only for discrete random variables. And basically you have the probability of an event A occurring is, some value, and the probability that A does not occur is some other value. And these are mutually exclusive events, so you can either have a successful event or a not successful event, and that's the only way the probability can occur. Then what you have is it's basically like flipping a coin. Like you can either get a heads. If heads is your event A, getting a heads, and that means that probability of A would be 1/2. It's a success. You got what you were looking for, and then the probability of A bar would be that you didn't get the heads. And in this case, it would be tails. Now you could roll a dice, and you could say the probability of event A occurring would be getting a 1, and that would be success. And then if you got a 2 through a 6, then that would be a failure. Okay, so you can only have two possibilities. So that's one. Only two possible outcomes. And it is success and failure. Okay? The second thing that you need for this is that they call this lowercase p, and so that's fine. So the probability is p. Okay? So the probability of A occurring is p. The second thing is that p is a constant, which just means that if you roll the dice doesn't lose mass or become sticky or change in any sort of way. The dice is constant or whatever event is happening. For a dice, this is kind of ridiculous, but if you can think of a car, for example, as you drive it, the car ages, and so perhaps the probability of something failing actually changes with time because of the environment that affects the system, right? So this is saying that every time you do a trial, and that's number 3, is that you conduct n independent trials. And so the idea there is that every time you conduct a trial, every time you do a test, it's completely independent from the one before. Okay? The binomial distribution, basically, you read it like this. Find the probability, and this is capital P. I'm going to put a serif underneath it to denote what a capital P is and a lowercase p. And so this says, find the probability P of having R number of successful events out of n trials. Okay? So an example would be if a success was rolling a 1 and I roll 10 times, what's the probability that I will roll a 1 4 times if I roll the dice 10 times? That might be kind of confusing. But the formula is pretty simple. It's n take r, okay, and let me make sure I have everything on here. So n is the number of independent trials, r is the number of successful events out of n trials, and then lowercase p is the probability that event A occurs in a single trial. Okay? So it's n take r, p raised to the r, 1 minus p, n minus r. And what is n take r? So you read this n take r, and n take r is equal to n factorial over r factorial, n minus r factorial. Okay? The mean is equal to n times p, right? So if you have a probability of success and you do n trials, then your mean should be that, okay? The standard deviation sigma is square root of np 1 minus p. And then there's a couple other variations, like if you want to find the probability that something is, like what about, you know, the probability that I roll at least 4 or 3 or 2 or 1 times, you would just add up the probability of 1, probability of 2, probability of 3, probability of 4, and I think that's just pretty intuitive. Again, there's some examples. I'm going to read this to you. I'm not going to solve the problem, but here's basically the idea. A light bulb manufacturer has discovered that for a given batch, 10% of the light bulbs are defective, so that would be the probability P would be 10%. If we buy 4 of these light bulbs, so N would be 4 in that case, that's the number of independent trials. What are the probability of finding that 4, 3, 2, 1, and none of the bulbs are defective? So you would go through and you would just substitute in 4, 3, 2, and 1 into this R here and just compute this equation and you'd be done. And again, there's an example in here. I'm going to put some homework on this and you can ask away if you have questions. All right, that's binomial distribution, and I hope you enjoyed this lecture.